Recording cycled. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on Twitch. No engine, no libraries. It's time for us to kind of to get down to it here. Last week we ended on Friday with some perspective projection, which means that our Z code is basically working now as far as the renderer is concerned, which leaves us with one remaining thing left to do, which is to start digging into how we are representing Z levels in the world, kind of this last sticking point. We've been dancing around it for a while. It's been the bane of our existence for quite some time because, again, in a 3D game, it's easy to conceptualize Z. It's just another thing that's treated the same as everything else. But in a 2D game, we have to do all these kind of gyrations to think about exactly how we want to handle Z if we want to do it in an interesting, robust way. And most 2D games don't, but again, since this is a programming series, we want to kind of tackle this head on and show how to confront an interesting technical problem like this where there aren't really right answers, only trade-offs, and show how we make trade-offs that lead us to a good place in terms of code. So what I'd like to do is get right back into that, but before I do, let me just mention briefly, it is day 109 here on Handmade Hero, which means that if you have pre-ordered the game on handmadehero.org and you want to follow along with the code that I am doing, you will want to unpack day 108 source code because that is what I am working with today, and that is what we will be using as a basis for the code that we do right now. So here's where we were at. We left off on Friday. We had fixed our perspective transform, and you can see that we're not drawing a ground right now so that we can see actually the tree rings that go increasingly back into the distance, so we can see 3 levels of the world. Now, it actually goes much further than that, the world does. I think it goes, I don't even know how far it goes down, but very, very far. I want to say it may go 2,000 rooms deep right now. I'm not sure if I'm right about that, but I think we may generate 2,000 rooms straight down. And what we do right now is we actually have some little simple yellow rectangles here that we can walk down, right? And we walk down them, the top level fades out and a new level fades in at the bottom. So we're totally set with how that works, and the perspective is looking pretty correct here. Our renderer is completely unoptimized right now, so it's still a bit slow, but that's totally fine because that's something that we'll be getting to sometime soon anyway. So what we need to do now is we need to have a little bit of a more coherent idea about how we're handling these Z levels. We wanted to quickly check the perspective map just to make sure we didn't have anything weird in there. I was a little nervous about the actual values we plugged in for our monitor distance and stuff into our math. So we want to take a little bit of a look at that, but what we would like to do after that is just get back to the issue at hand, which is figuring out how to represent these Z values in terms of storage and in terms of other stuff so that we can kind of get, just a better feel for them. So I guess one thing that I would like to do now is just say, all right, let's take a look at that perspective projection and let's think about what we're actually representing in the world here and how we want it to appear, how it should appear in terms of how big it actually was, and we'll see if things make some sense. Now, I agree that the way that I've tuned it here is probably not super realistic. If these are actually stories of a building, you have to figure that probably they'd be a little bit more separated than they are now, right? And so probably I tuned it a little conservatively, and so really it's not maybe as bad as I made it out to be, but I think it still is a little wonky, so maybe we'll take a look at that. But let's go in here. Let's say we switched it to something a little bit more like that. That looks a little bit more correct to me in terms of maybe if it actually was sort of more like the story of a building like it's supposed to be. We set it to 3 meters, which is around 1 story height for a building. Certainly not cathedral ceilings, but something that's a regular height that should actually be right. And that probably is a little bit better than it was than I had it tuned, right? But looking at that as a set of parameters, right? If that looks particularly reasonable, backing out what's in here, right? What we're essentially saying is kind of weird. Like, what this is saying is that the camera distance above the target, which is the place that we're looking at, the camera distance above the target, we're setting it to the same thing as the focal length, right? And I guess, that could be a reasonable, that's the thing that was weirding me out, basically. That could be totally reasonable, but I want to kind of explain what that is and why I was a little nervous about it, just because it doesn't really line up with what I was expecting to see, and when things don't line up with what you're expecting to see, it's usually worth taking another look at them. Now, granted, what I'm expecting to see as a person who programs 3D graphics for a living may not be what you should see in a 2D game, and this may just be a learning experience for me where I'm going, oh, okay, in a 2D game, because of the way the art it works and the 2D-ness, it actually does make some sense, but, you know, just in case there's some additional drama in here, I want to make sure that we understand it, right? So let's talk about this for a second. So fundamentally speaking, we've got a world down here, right? And we've got some trees that we're talking about here on these plates. And then we've got another plate below it. Here's another, you know, with some more trees that go around in a ring, right? Blah, 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 right? The trees go all the way around. And in the middle of this, there's an imaginary target, and we're imagining that the camera, right, Z comes up like this. This is the Z-axis. And there's an imaginary point that we're basically calling the camera, right, that is looking down on this stuff, right? The camera's kind of looking down to see these things. And what I was expecting is I was expecting to have, you know, basically a parameter here that was the monitor, right? Sort of the monitor is here, basically. And that distance here was our focal length, right? And then I was expecting to have some other distance here, which is how far the camera is from the target, right? This is the camera distance to the target. And that's what we base the perspective equation on, because basically we're taking these things and we're projecting them onto this imaginary monitor here, and we're using these two parameters to do so. Now, what I realized after we did that I thought might be part of the confusion is what we did not do anywhere implicitly is we never actually said how big the monitor is, right? So we have meters to pixels, and meters to pixels is just a value that we specified randomly back in the day. And meters to pixels is entirely implicitly defining the size of the actual monitor. Now, we didn't define the size of the monitor based on its actual size in any way, right? So the fact that the monitor itself, its size is being represented in meters to pixels, could be one of the reasons why these values don't make a lot of sense. It could be that meters to pixels is actually a very, very wrong value because we set meters to pixels based on an arbitrary thing when we had an orthographic projection that wasn't doing any of this. And so what I wanted to do today is just go, how big is the actual monitor? How would this work out if we actually defined its size and how big we expected pixels to be in world units and that sort of thing, right? So, what I wanted to do is go take a look at meters to pixels, right? Because that gets set back in here somewhere, meters to pixels, right? And basically what we said here is that a pixel, right, is 42, I'm sorry, a meter is 42 pixels, right? That's how big a meter is, right? And so I think the reason that there's a 10 in here, and in fact, now that I'm even looking at this, I think my suspicion from after the stream on Friday was very much correct. Meters to pixels as 42. Well, where are the pixels in this diagram? We were talking about them as if they were here back in the day when we were doing meters to pixels because it was an orthographic projection. But now, where are the pixels? Where the pixels are on this plane. So if we are saying that basically 1 meter equals 42 pixels, then now we have to ask ourselves, how big is our monitor? Right? It's a legitimate question. Let's go ahead and see what our dimension is, right? When we actually create our display surface. So somewhere in here, right, we've got a client width and height kind of a thing going on here. Let's see, create window. Where do we do this? I don't actually want to create window. I want to create where we create our back buffer. We have 960 by 540, right? So we have a 960 by 540 monitor. And we're saying that for every 42 pixels, we have a meter, right? So if I were to back out the math, right? If I do 960 divided by 42, right? 960 divided by 42. That gives me a monitor size of 22.85 meters, right? 22.85 meters across, right? So this is the size of our monitor across. And then 540, oops, I didn't round that properly, 857 should be 6 meters, there we go. And then 540 divided by 42 is 12 meters down, right? 12.86 meters down, right? So that means our monitor, right, is the size of a room, basically. This is like the size of an apartment, right? That is a very, very, very large monitor. In fact, you might say that it's about 10 times the size of a monitor. And hey, guess what? That is exactly the number that you have to plug in here to get these values to feel more correct. So I suspect what is actually happening here is that our meters to pixel value is completely erroneous and actually does not in any way represent what should be going on with our world coordinate system. So I feel like we've got to fix that, right? I feel like that's something we're going to want to repair, right? And so maybe we shouldn't tackle any more Z stuff today. Maybe we should just go through and make sure that our meters to pixels is actually going to be something that works correctly. So let's take a look at this here. Let's think about this for a second. So basically, meters to pixels is used in only really two places now, if I remember correctly, right? I believe that meters to pixels is essentially used only to compute our actual projection, which is where we want to use it, but also in one place where it's kind of annoying to have to use it, but it's basically where we compute our bitmap offsets, right? And the reason that we need it there is because our bitmap offsets are in pixels, because that is how we know, like, that's how we measure them, right? So there's a couple ways that we could try and mitigate that fact. In fact, there's a couple ways I can think of right now to mitigate that fact. So maybe what we should do is try to get meters to pixels out of the pipeline entirely by converting the values that we currently need it for into something else, if that makes sense, right? And if we do that, then we can set our perspective transform up so that it's the only place that thinks about how pixels and world units interact, and the rest of the game never thinks about it at all. I think that's a pretty important thing to want to do, because that way it makes it easier for us when we go to start supporting multiple resolutions at the same time. It makes it so that that's not some big ordeal, right? We want to be able to just say, okay, if we want to change the resolution to 1920 by 1080 from our, from our current resolution, it's just a simple thing to do, and it's not this big sort of ordeal where we have to think about everyone who's thinking about pixels, right? We want basically as few people as possible ever thinking about pixels so that we can be resolution independent up to as far of a point as we want to be, right? So what I'd like to do is I'd like to go ahead and suggest that perhaps we just encode our hotspots as being proportional to the size of the bitmaps themselves, right? So instead of having them be proportional to this meters to pixel stuff, instead we can just have our bitmaps not have any of that information, not have any of that sort of concept at all, right? So if we take a look at Handmade Render Group, right, you can see how we've got this V2 aligned right now, and right now that's in pixels, right? But what we could do here is we could sort of say that, well, what if that was a line percentage, right? So the loaded bitmap was actually saying what its alignment point was as a percentage of its width and height. That way it can be passed through without ever being multiplied out, right? It can always be in some independent thing that will be the same whether the units are meters or pixels or anything else, right? Because a percentage of a distance is the same whether you're measuring it in pixels or measuring it in anything else, right? So if I was to change this to a line percentage, let's see what that would do to the code, right? So when I am doing this sort of operation here, where we're like, okay, meters to pixels, offset, and then we have a line, whatever. When we do our push bitmap call, in this case, I believe that we never actually at this point specify how big we want that thing to be. So okay, this is going to be, I think this might actually be even more interesting. So this is all good. I'm feeling good about this. I think this is probably what we should do. So I'm going to go ahead and go down this road. There's 2 steps we need to take, and I'm going to see about taking both of them. So the first step is to extract out that alignment, but it's still going to introduce one thing that has to do with meters to pixels, and you'll see that in 1 second, right? So what I want to do is introduce the alignment here. So what happens if I was going to do that? If I want to pull this alignment out as alignment percentage, I need something to multiply it by, right? So I need to make this alignment like so, and my bitmap align percentage here, I need to multiply it by something that is a reasonable percentage, right? Now, since we're still in pixels everywhere, I actually know what that percentage is supposed to be. It's supposed to be in pixels because this is accepting pixels right here. So what I need to do is say, all right, I just need the bitmap width and height, right? And then if I multiply the percentage, the align percentage by that bitmap width and height, that will give me where that alignment point is, right? So let's go ahead and take a look here. What did I do there? Bitmap align percent. Oh, right. This is a Handmade product, right? It's a vector product. Let's go ahead and do that. So when we do this this alignment stuff here now, we've got a little more work to do. You can kind of see that we've got a few places. Just there's not very many, but there's a few places that set this alignment. So now these things, what they have to do is they have to basically be smart about the way they encode things. So right now we've got this alignment. It gets passed in. But it's not a proportion of the width and the height. So in order to do that, what we want to do, I believe we have a safe ratio function. Do we not have a safe ratio function? I'm going to take a look and see if we do here. Safe ratio, we do. So I'll do safe ratio 1, let's say. Well, actually, we'll do safe ratio 0. So safe ratio 0 and produce a ratio of these where we encode the x and the y based on that bitmap width and height, right? So it's the same alignment value. It's just instead now we're changing it to mean the percentage, right, of the width and height, okay? Hopefully that makes sense. So let's take a look here. We've got, okay, these guys have to be converted to floats, which is fine. We've got a line percentage here instead of a line. And then these guys as well are all going to be align percentages like that. And then we just have to see, oops, didn't mean to do that. And then we just have to see whether or not any of that works. I don't know if it will. Looks totally fine to me, right? So basically we've got essentially the exact same thing as we had before. Let's just make sure that our offsets are working as we expect they are. They do look like they are. Everything's kind of works as I expect it there, so that's all good. Nothing particularly weird happening there. So that's good. All right. So that totally eliminated one of our meters to pixels things, right? Which is now we're storing these as a percentage. But unfortunately, we're still using the width and the height of the bitmap actually when we go to store our actual, excuse me, our actual data there, right? When we do that push, we're still using the width and the height of the bitmap, which means that this is still, meters to pixels is still getting directly used in the actual encode call. And what we'd like to do is we'd like to get rid of that, basically. So what I want to do is I want to introduce the concept that the bitmap itself, right, also has sort of a native scale value that says what the scale is based on the bitmap, what its native scale is x to y, right? In other words, what I want to do is say, okay, we've got a thing which is like y x like this, right? And what I want to do is say, okay, from now on, we need to actually say how big things are going to be on the screen. We're going to give those in actual meters from now on. So when we say how tall the guy is, we're going to give that in meters, right? We're going to say how tall the guy should be in meters. So when we do that, what I'd like to do is say how tall he is in meters in one dimension, right? Like y, I'll give the y value, and then it'll solve for the x value, right? Well, not solve, it'll compute the x value based on a multiplication, knowing what essentially the aspect ratio of the sprite is. Meaning I'll say whatever the x pixel width is, right? Well, I guess we'll do it this way. Pixel width over pixel height will be something that we store with a bitmap. And when we do this, right, the fact that this is in pixels, right, it's like 32 pixels over 60 pixels or whatever, pixels cancels out, and we end up with just a dimensionless ratio, right? It no longer cares that it's in pixels. And so again, that will help me to eliminate pixels entirely from the pipeline here by just specifying that and getting back to sort of a pixel neutral way of specifying things. So let's go ahead and take that step, right? And let's say width to height, right? Or I guess we'll say width over height, right? Something like that. So it's just a scale value that says if I have a height value, I can multiply by this to get the width out of it, no matter what it is, okay? So what I need to do now is every time we actually load a bitmap, I need to go ahead and compute that value. But that is not very hard to compute, right? It's just a simple ratio. So every time we do a debug load bitmap, it's pretty trivial for us to just go ahead and store that value, right? Width over height is just going to be a simple ratio. Well, in fact, I'll use safe ratio 1 for now. I guess, well, 0 is probably better if the well, it doesn't really matter. There should never be a bitmap that doesn't have both values being greater than 0, right? So what I want to do is take the ratio here, the result width and the result height, take the ratio between the two and produce that value. And so then that will give me a permanent way of doing that computation, right? And again, I guess I got to upconvert those to floats since they're by default integers. Once I have that, now when we go to do our push bitmap calls, right? Instead of the old days where we had meters to pixels governing everything, what I'd like to do is just say, okay, from now on, what we're going to do is we're actually going to say how big we expect things to be, right? How big in meters we expect them to be. And we can actually, when we load things, if we want to keep our current way of doing things, right? If we don't want to disrupt the way we're doing it now, and we essentially want to base the size of everything off of how big its bitmap was, which we probably don't really want to do, but you know, we could do that. We could say it's like native height value or whatever is based on that meters to pixels value, right? So we can still keep the old meters to pixels in here if we want to, right? Which would just be the native height of the bitmap, and that's just going to be whatever the height was divided by meters to pixels, right? Or more explicitly, pixels to meters times that, right? And that would mean that this, when we do that read, right, whenever we read a bitmap, we would have to say what we want our pixels to meters to be. But what I think we can do now, if we do it this way, is we could make it so that literally the bitmap loading routine is the only thing now that ever cares about pixels to meters at all. So what I'm going to do is I'm going to go grab meters to pixels right here, and I'm going to go ahead and go back up to this function and just paste that in here. So I'm going to say pixels to meters right here, and I'm going to say that that's, you know, right there. That's so for every 42 pixels, there's a meter, right? Which I think is probably not how big. I don't know if that's how big we want it to be. Maybe that is how big things should have been. I'm not sure. I don't remember. We'll have to think about that. It seems a little odd, but well, doesn't matter. Never mind. Ignore that for now. We'll think about that for a second a little bit later. But let's say we go ahead and do that. We now have everything that we need in order to basically do this completely without any values in the pipeline at all. So let's go ahead and take a look at meters to pixels and where that is used. Right, you can see that essentially it's really something that's basically only used in the render group, right? It's not really used anywhere else. So I'm going to go ahead and try to get rid of that. I'm going to go ahead and get rid of that. I'll take a look at the game state value. We'll see if we can get rid of it. Meters to pixels and pixels to meters, right? I'm just going to go ahead and try to excise that, right? So this is going to be a little bit the world chunk dim and meters stuff. This stuff right here, we need to start thinking about a little bit differently. Anyway, when we do those world chunks, we don't actually care what the pixel values are of these. This is going to be something we're going to do a little bit differently. But for now, we will leave this guy just in here, but only just there. So let's do this. Move this. All right. Let's just use that this way, because I don't want to actually deal with the ground buffers just yet, since they're not even turned on at the moment. Let's see here. And get rid of that guy. Now we go over to the render group. Meters to pixels goes away. And the allocate render group call, allocate render group, takes that out of the equation, like so. And now we just have to go in and actually clean up anywhere that was doing this. So what does the screen width in meters have to do with anything here? Okay, so this is another good example. Like this right here is a good example of also why we don't want to do it, because this is essentially a culling value, right? This camera bounds in meters. And what we want to do is we eventually want to set this based on what the renderer thinks you can see. So this is actually another good example of some place where we really want to start cleaning up this, because this should be the renderer that tells us how big we actually want those camera bounds to be, I should think, if that makes sense. That's just my guess anyway. But yeah, at the moment, it's unclear what we want to do with that. So I'm going to leave that just for now, just so we can get all of the renderer working with no pixels to meters. And then we will see if we can remove pixels to meters entirely. Or if we don't remove it entirely, have it in a place where we know that there's a couple coherent values that are computed with it, and then we throw it away, right? So let's take a look here. Essentially now, when we get the entity basis P stuff, this will be something that will be the routine that we actually do the work in. But now everybody else, I believe, can get rid of the pixels to meters stuff. So I'm going to go ahead and see if we can just excise that entirely. Draw a rectangle slowly is still taking that pixels to meters. Yeah. So this is our reflection thing here. Yeah, and that's just using it to figure out how much it wants to move, by. All right, so I'm going to go ahead and nerf this guy for a second here. Again, I'm just trying to pare down the amount of code that we have to use to get rid of this. Let's see here. And technically, I suppose I don't actually have to do this. In fact, now that I think about it, I don't actually have to get rid of this from the renderer. I'm trying to get rid of this from everyone external to the renderer and from all of the storage. So I suppose technically this routine having it isn't necessarily a bad thing. I could be okay with that. I'm not sure yet. I'll have to think about that. I'll have to think about that a little. All right, I'm going to let that sit for a second. So I'm going to leave that in here. I'm going to leave that there. And then I'm going to remove basically that from the rest of these guys here. Okay, so draw a rectangle slowly. So here's our push bitmap call. What I want to do now is just say, okay, when we do a push bitmap call, the size of this thing we are going to know now, because the actual size of the bitmap is going to be whatever that bitmap native height is, right? Is going to be one parameter, and the bitmap native height times the bitmap width over height is going to be the width, right? And now it may seem weird that I'm doing that instead of just having the native height and the native width in here. But the reason I want to do that is because soon what we'll do is we'll just start passing in what we want the height to be, and then that way everything has its own height specified, right? And those people who have constantly been saying, when can we shrink the hero down? We can finally shrink the hero down today. I know that there are many people who it bothers them that the hero is too tall right now. This would be the time you could do that if you wanted to. All right. Okay. So we go do our alignment here. The alignment now is going to be an alignment percentage times the size, right? Times that size vector, which is how big the thing is going to be drawn. And what I'd like to do as well is now inside the push bitmap call, because we weren't doing this before, eventually what I'd like to do is also, in fact, I guess I will just do it here. I'm going to record the size right in here when we do that push, because I'd like to keep that size because I'm going to use it in the drawing loop, right? That's how big I want this thing to be in meters on the screen, right? In meters in the world. Okay. So let's go back up. Well, actually, I guess let me remove it from these other ones here. Let's remove meters to pixels from this stuff, like so. There we go. Meters to pixels. Is it used anywhere else? Not really. It's only used in here and here. So if I do pixels to meters here, that was 42 for now. Do Casey. Remove this, or remote this, as the case may be. And so now when we do our get render entity basis p, right, essentially we now have a thing where we can start to think about this perspective transform as actually operating in meters, right? I can get rid of the meters to pixels entirely here. All right, I can get rid of it here, I can get rid of it here, I can get rid of all of this stuff, so that now it's no longer happening. There's no longer any meters to pixels happening at all. It's just entirely happening in meters, right? And once this all happens in meters, then I can go ahead and at the very end convert it out to pixels by just multiplying by whatever that factor should be, right? And that factor is going to differ. The meters to pixels factor is going to differ based on the resolution of the screen, right? Because I want it to be the same effect regardless of whether the screen has 940 or 1980 or however many pixels it has, right? So really what I want to do here is when I do this result P and I do screen center plus projected XY, right? Really what I want to do is I want to do something more like a traditional projection. And really there's two sort of ways that we could do this. One way rolls them both into one multiplication. Another way does a transform to a unit cube and then out. And I don't know that we really want to talk about that too much because it's not super relevant, but I'll mention it briefly just so those of you who have 3D aspirations will kind of know what I mean. So when you're dealing with 2D art, you have a lot of advantages, which is that clipping is not a particularly difficult thing for you. Clipping is actually relatively trivial, and it's essentially something that is very hard to go wrong. You can essentially do something called guard band clipping for mostly everything, and the culling is very straightforward. You don't have angled things. Just a lot of things go your way. In 3D, you don't actually have that luxury, and so what they typically do is they use a thing called the unit cube, and they clip to a 4D unit homogeneous cube, okay? What this thing is it's basically, you can imagine it just the 3D part of the cube, actually. It's all good, right? Let's go in here. You can sort of imagine going to a unit cube, right? If you wanted to do clipping so that you could figure out, like, all right, here is the shape of the monitor, let's say. The monitor is always going to be this front face here, right? This face right here. This is the monitor, and the entire world fits in this unit cube, okay? So everything in the world has been shrunk down, aligned, and squashed into this unit cube. What typically happens in 3D projection is that you do actually do exactly that, right? You have some notion of the camera, right? You have the world out here. You take the frustum that you can actually see of the world, okay? This is the near clip plane, and this is the far clip plane, okay? you take this frustum and you literally warp it so that it fits into this thing, right? This part, right, comes out to like there or whatever, right? Over here, you know, this part right here comes out to over there or whatever. It's, you know, kind of gets maps in here. And the clipping happens now in this uniform cube space. So this part gets, you know, thrown out and this part gets kept, right? And the clipping happens to produce the correct fragments that should happen. The triangles as they need to be clipped are actually clipped in that unit cube space, okay? So all of the coordinates that you have when you do your projection, when you actually do the matrix, the projection matrix, when you actually do essentially this step right here, all of your coordinates are actually between -1 and 1, right? So x, y, and z are all between -1 and 1, or if you're in direct 3D, there's actually, it might be between 0 and 1, the z value. They did some stupid stuff. But anyway, assuming you're in OpenGL, it's all between -1 and 1. So first you do this smush, then they do the clipping. Again, this is done on the GPU. You are typically not doing the clipping. You just provide the projection matrix that does this smush. So you do the smush, the GPU does the clipping, and then the GPU blows out these -1 to 1 coordinates into actual screen coordinates, right? So it multiplies by the pixel width and height, right? And adjusts for the fact that the center was here and now the center is going to be down here. So it actually applies an offset as well to actually figure out where the pixels are, right? And so basically there's like this concept of first you do the smoosh, right? And then you do the blowout, right? That's not what they're called. This is typically called like view to window transform or something like that, right? Or you know, like clip space to window space might be another term for it, right? This, however, is called the projection, certainly. This is the projection matrix that does this, et cetera, et cetera. So that's basically the capsule overview. Now, we don't have to do this step. There's really no reason for us to care about this at all. It's really just not something we're going to have to worry about. So what that means is we don't actually have to do the smoosh. We can just have one value, because if you think about what the smoosh does, essentially there's a meters, you know, world units, there's a world to unit cube transform, and then there's a unit cube to pixels transform, right? And so there's two scale factors. There's one that transforms the world into the unit cube, one that transfers the unit cube into the pixels. What we can do instead is just do world to pixels directly, and that's why we could, if we want to, and I think we probably should, just to keep things simpler, just have essentially a meters to pixel value like we did, right? We should just be able to use one value instead of splitting it into two values, even though that mirrors more what happens in the 3D pipeline, because we really don't care, right? We don't care about that in the 3D pipeline. So, okay. So let's say we want to do that, right? Now maybe that's a bad decision, because maybe when we go to do the OpenGL path, we'll want to, you know, we'll want it to be done more symmetrically on both sides, and, you know, we'll cross that bridge when we come to it. For now, I don't think we really have to care. And so basically what happens is when we do this projected XY, this is doing the projection in meters in world units, right? And off it goes. I'm going to delete that to do for now, because that's what we're actually doing right now. And so then right here, what we need to do is this is the place where we actually need to do that projection, right? So here's the place where we actually need to do meters to pixels, the only place that we actually need meters to pixels, at least for the time being, right? All right, and so if we back that out and we do meters to pixels here, right? And that was this way, I believe. Oops, sorry, that was this way, right? That gives us the only place that we actually needed to use that. Okay, so we got meters to pixels here. Why is bitmap still doing this? Don't want it to be doing that. That's not what it should be doing at all. Allocate render group. What is it doing? Allocate renders group has meters to pixels. It had it set to 1. That doesn't make a whole, well, all right, doesn't matter. We'll cross that bridge when we come to it. So yeah. So as you can see now, we've got our dudes. They're still exactly the same size as they were, because they are passing that native height in, and so everything works just fine with them, or actually, you know what? Are we actually using that? We're not using that right. They may be busted now that I think about it. We got to go in and let me fix that there. Let's see. I don't think they're busted though. I think everything's fine. So right here, where we do this basis scale, bitmap width, and bitmap height, this I really just want to now use the scale value that we had in there originally. I probably should have said scale. Maybe we'll change that name in a second when we start to clean these things up. Entry size.y. There we go. So let's take a look here. Draw rectangle slowly. Oh, right. Sorry. Did that a little bit stupidly. There we go. What I actually wanted to do was put it here. Right, size.x, entry, size.y. Now, I don't actually know, no object file generated. Right, this is not a v2i anymore, it's just a v2. Don't actually know if that's all good now. Okay, so our I love when they get tiny. They end up moving so quickly. Okay, so now we have to go in and actually debug what I just did there. But we're getting a little closer. We're getting a little closer to having meters to pixels out of the equation, which is what I want. Okay, so when we do this, we've got our sizes in here. Our basis scale, I believe, is right. The basis scale is just allowing us, is what does that perspective transform there. So get render entity basis p. Like here, that is still all working as I would expect, right? We've got meters to pixels operating here just on the final output projected xy, which is what I want. This scale, however, so I guess we also need the scale value because we only compute that z. We actually need our scale value. That's probably what our problem was there. We need to scale up that report back for actually producing the pixel-based size. So there we go. All right. Okay. So now we're almost there. We've gotten down to we've gotten down quite a bit. So let's go ahead and take one more step here. What I'd like to do now is to have push bitmap, right? I'd like push bitmap to start specifying the size that it thinks things should be, right? So in push bitmap, where is my push bitmap call? Right here. What I want push bitmap to do is I want push bitmap to start taking a scale. So in addition to an offset, I want to basically take, a height in the world, so that, when it comes in here, we're not going to be using native height anymore. We're just going to be using height. That's what I'd like to do. So what I'm going to do is say we'll do it this way, height and height, like that. And then all of these push bitmap calls are going to have a height value that's like how big they want things to be. Now, I don't actually know what a lot of these should be. We'll have to play with this. When we do our ground splats, again, we'll have to go in and sort of redo that, but that's fine. That's sort of that's a pending piece of code anyway. So, all right, what did I do? I put that in the wrong place. That's kind of not what you want, so let's fix that. There we go. Like so. Push bitmap here. So now we've got a bunch of these things, like the shadow, the torso, the head, and the cape. Now we know that all of these things are actually the full height of the guy. So I forget how big we decided we want our dude to be. Let me go take a look at how big we wanted our guy to be. We had a thing in here for that, actually, right? We had when we add a hero or whatever. Let's see, where's add player? We had a thing that said how big we thought they were supposed to be, right? Because we added collision for them. So player collision looks like it's about 1.2 meters tall, right? Is that, how big is that? 1.2 meters in feet. About 4 foot tall, that seems fine. So what I want to do here is say, all right, the dude's about 1.2 meters tall, right? Now it's a little weird because we're specifying that, but is he a little oblique? I don't know. But whatever, that's what we're going to say. So that's where that is. How big the shadow should be, I don't actually know. I don't know, maybe the shadow's about 0.25 tall, something like that. What is this? Why cannot convert? Why do I always want to put it before the position, and I feel like that indicates to me that it should just go before the position. So you know what? There it is. It is now before the position. Usually you should just design APIs around what people actually do rather than what you would like them to do. So if that's what I'm doing, that is what I will make happen. So now, how tall is a tree? I don't know. Maybe the tree is 3 meters tall. I'm not sure. Although if a tree is 3 meters tall, it's taller. How tall is that's a full story high. So maybe we want our trees to be, you know, very short and stumpy trees, I guess is how that, you know, works out. I don't know how big a sword should be. Maybe let's say 0.5 meter. I'm not sure. Again, these are values that we'll tune. And let's see, a head, we'll just leave those at 0.5 meter as well. I'm not doing anything intelligent here because we don't care what these values work out to be at all. All right, so if I go ahead and run this now, let's see. I'm not sure, that doesn't look quite right for how high the guy is relative to the tree. Does it? I think so. I may have a bug there. I want to take a look at this because let's take a look. So if I'm standing here, right, and my guy is 1.2 meters, well, maybe that's not a bug. Let's see. So how big is the tree? The tree is 2.5 meters, and my guy is what? My guy is, oh, but you know what? There is one thing that I have to sort of count on here that I'm not counting on, which is how much space is actually in the hero bitmap that's not being used. So hold on one second, I want to take a look at that because we're saying what the height of the bitmap is, and the bitmap doesn't necessarily end right at his head, right? So let's take a look here. Actually, it's in test 1. Let me take a look at the test hero. Let's see, let me take a look at the front head there. I'm going to edit that with GIMP. Hello, GIMP. No rush on the loading there, GIMP. Take your time. So yeah, so there's a big old empty space at the top of his head too. And at the bottom too, probably actually. So if we take a look at where the torso ends, right? There's a big old empty space there too, actually. So really, this guy is unfortunately not at all the correct size in the bitmap. So I don't know how we want to handle that at the moment. But basically what that means is that he needs to be synthetically scaled up a bit from what his actual size is, right? Because it looks like he's about an extra like third or something like this, right? In addition to where he should actually be. So that's more like it. And that actually does look relatively reasonable, right? That looks like he's now more or less the right size relative to the tree, if that makes sense, right? That looks like how big he should look near to a tree. Now, I don't super love that, right? If that's how big he actually should be, right? I don't super love how big he is relative to the tree. So I think we want to cheat that a little bit. I feel like we want him to be closer to the size of an actual tree because that's the aesthetic of a 2D game. So I feel like we actually want like a hero size coefficient to be, you know, some kind of a erroneous value here. Let's go ahead and put that in there, right? So now the hero is, you know, is about that size. And that seems pretty good relative to the tree. Now I would also like to be a little closer at this point. So let's go ahead and fix that as well. I don't actually know why I just closed the game. There was no reason to do that. But let's go ahead and go up here to get render entity basis. And what I'd like to do here is first of all see, okay, what's the deal with the focal length now? I feel like this focal length should actually be much smaller than it was. But in order to look at a whole room, maybe we do need a fairly long focal length. I'm not sure. But it does seem weird. So I'm gonna play with these values now that they're a little bit different. I'm just gonna see if some more reasonable values to put in here make sense now at all, or if they don't, if they still don't. So they still don't quite make any sense in terms of what we've got going on here. So I'll leave them as they were for a moment. Let's go ahead and tweak that till we get to something a little more usable. Let's see here. I feel like that's a little, still want to be a little closer than that. Let's see here. So maybe we go to something like that. And that's getting closer to what I would expect the game to look like. So something like this. Yeah. That's getting closer to good, certainly. It's getting closer. It's not sure exactly. We'll have to see once we actually get some stuff in there exactly what the size should be, but that feels a little more reasonable to me on the whole. I think that's pretty good. Might want to make the hero just a little bit bigger. So let's go ahead and do that as well. I like having the hero be roughly the size of a tree, even though he should not be. It just feels right to me. So that feels a little bit better. Again, we have a bunch of bitmap issues to work out there. So let's go ahead through now, now that we're a little closer to what we want, yeah, and start cleaning this stuff up. Okay. So now that we've got this sort of stuff happening here, we have a couple other issues. One is that our collision sizes, we want those to line up with the size of the hero probably, which at this point they won't necessarily. So I feel like that's something we're probably going to have to take a look at relatively soon. But I want to focus at the moment on just that meter stuff, just so we can kind of finish that out. So now I think we can get rid of the native height stuff. The native height stuff can just go away, if that makes sense, because I don't think we actually need it for any particular purpose. So let's go ahead and nuke that. There we go. And get rid of it there. Right? So that gets rid of most of that stuff. And that means that now we've only got this, we've got our pixels to meters getting used in just a couple places here, right? Just in basically computing that screen area, right? And then in the renderer. Okay. So let's go ahead and get rid of it in the renderer. Let's do just a little bit more there. So I think, unless otherwise specified, all inputs to the renderer are in world coordinates meters, not pixels. Anything specified. So I guess we pretty much don't want meters, I mean pixels ever. So I think what we want to do here is something like it is mandatory that all inputs to the renderer are in world coordinates, not pixels. If for some reason something absolutely has to be specified in pixels, that will be explicitly marked in the API. But this should occur exceedingly sparingly. Okay. So, oops, meters. Let's take a look. So we have two places that use it now. We've got it in the render entity basis P stuff, right? We've got it in here. And then we've also got it in where we're passing it to the draw rectangle slowly call. And so I just want to take a look at what the draw rectangle slowly call is doing. I believe all the draw rectangle slowly call is doing is using it to do its own projection into the map when it moves. So I'm going to say that that's okay for now, but I don't know that we actually want that to stay forever. But anyway, what we will do is I will leave it going so that it actually passes through here. So let's take a look at pixels to meters as it comes in here. So we've got, that's not the one I wanted. where is that get render entity basis? So we've got this working up to the point where then it finally at the end has to put stuff out into pixel space, right? And in order to make this work properly, what I want to do is I want to have this be based on how big the screen actually is. So when it calls get render entity basis p, I want it to actually pass in how big this output target is, right? So basically, there's something like a screen dimension, you know, and the screen dimension is this, right? And then that screen center is just going to be 0.5 times that. And so I actually think, is screen center only ever used when it passes? Yeah. So what I'd like to do there is get rid of that potentially. Take a look at the screen center thing when it's happening here, and instead pass the screen dimension, right? Because that's something that can just be computed from that, right? So the screen center is just half of the screen dimension, right? So I'm going to pass that screen dimension in here. So there we go. All right. So if we compute it that way, what I want to now do is say, all right, meters to pixels, I don't actually want to use a fixed value for that because it'll be different depending on the monitor, right? The number of pixels on the display is going to determine how many pixels a meter maps to. So what I'd rather do is say how big a meter is on the screen, right? So what I want to say here is actually a different value. I want to say something like monitor width in meters, right? Something like that. And I want to say monitor width in world units might be the better way to say it. So how big do I want the monitor to be, right, if it was measured in the space of the world? And so how many world units across is that monitor going to be, right? And I think what I want to say is that, like, okay, if there was something that was, you know, taking up a certain amount of space on the screen, on the near clip plane, like right up against the monitor, you know, how many meters across should that be? And maybe I want to say it, maybe I even want to say it how many meters should something take up on the screen at a particular distance might be the other thing. But it's kind of hard. I'm just not sure how I want to specify this value exactly, right? But I want to do it in some percentage of the screen size. I guess we can just do it as a value and kind of tweak it to what we want. But maybe then we'll sort of back it out and try to figure out if it makes sense of the value, right? So what I want to do is say something, yeah, like monitor width, or I want to derive the meters to pixels value by basically going, oops. Oh no, I'm out of time? You're kidding me. Oh. Well, let me just finish what I was doing, and then we can kind of go from there. So what I want to do is I want to say the screen dimension, whatever that screen dimension x is, meters to pixels is basically going to be based on that screen dimension x, right? And so if the screen should be 3 meters width wide or something like that, right? Then however many meters to pixels is, it's going to be whatever that screen dimension is divided by, you know, whatever that number is. That's how many pixels are going to be in one of those chunks, right? And so at that point, it's now, you know, supposed to be more resolution independent. So in theory, I can get something that will be the same no matter which resolution I use, right? And I'll just take a little bit of time, just a baby bit of time from the Q&A to show what I mean by that, right? So assuming that I have it work like this, right? So now that it's based on that value, what I'm kind of saying here is, let's suppose that we were to change the dimension. Like, it looks like this, right? This is what it looks like, okay? And suppose that I went to go and change the dimension now to some other dimension, right? So, you know, let's say and in fact, let me do it the old way. So I'll just set it to 42 here. And here's my guy, right, at 42. Okay. And you can kind of see, like, you know, we're playing the game and we got how many trees across? 1, 2, 3, 4, 5, 6, 7 trees across, right? So then I go into Win32 Handmade, right? And I say, okay, instead of that, I want to change the back buffer to 1920 by 1080. We're going to use a high res here or whatever, right? It's just going to be high res. So we'll restart the game with a different back buffer, right? And now you can see it's like it's a different game, right? I can fit all the trees. I can fit all the trees across, and instead of only 7 across, I can fit 8 across and then probably 9, 10, or whatever, right? So what I wanted to do instead of that is I wanted to say, all right, let's make this based on the actual size of the screen, so that no matter what the resolution is actually set to, you know, it will work, right? So if we go in here and we say, all right, that's how big it is now, right? If that makes sense. If that's how big it is, you can see we can get 1, 2, 3, 4, 5, 6, 7, 8 of these on, and we don't quite get to that ninth there. I'm sorry, 7 on, and we don't quite get to the 8th. The 8th just kind of comes on as this one comes off, right? If that's the value, that's at 1920 by 1080. If I then go ahead and change the resolution to be back to a different value, right? The old value that it was, the lower res, right? I want this to basically be the same value. And so where are those trees? Let's see here. Can we get them to the right thing? Let's see here. 1, 2, 3, 4, 5, 6, and there's the 7th. Oh, but it should have been 8, right? So are we still a little bit off? I feel like that's still not quite right. Let me make sure. 1, 2, this is the topmost trees. 1, 2, 3, 4, 5, 6, and there's the 7th tree, right? Let's go ahead and put this back. What is, hold on a second. 1920 divided by 2. Oops, that's not right. 1920 divided by 2 is 960. 1080 divided by 2. These are correct, right? Just want to make sure I have the aspect ratio correct as well. Okay. Let's go back up to the high-res version. There's the actual trees. So yeah, it's still not quite correct. Oh, yes it is. We just can't see the end of the bitmap. 1, 2, 3, 4, 5, 6, and then there's that extra tree. There's just barely that beginning of it, because we can only this is a full 1920 by 1080. So there we go. And then if I go ahead and switch it back down again, we should have that exact same thing, right? And we do. So that's good. So we're getting there. We're getting there slowly but surely. Okay. So if that's our meters to pixels is computed that way, right? Our meters to pixels is computed there. Then the only problem we really have here is that, you know, we probably want, we've got pixels to meters being computed here as well. So what we want to do is make it so that it's at least uniform there. So we'll go ahead and pull that out. We'll say that that's happening right here. So we have meters to pixels, and then we have, you know, pixels to meters, like so. There we go. And then this will just take that value, meters to pixels. So at least then we're unified in there. And now we're going to have to do, we'll have to leave it to tomorrow because I don't want to eat up any more Q&A time, is what we'll have to do tomorrow is just make sure that we then have anyone external to the renderer who needs to know this stuff will get it from the renderer, so that it's not something that they just kind of do ad hoc outside of what, you know, what they're supposed to be doing, right? So let's put that in there, like so. Oops, meters to pixels. Thank you, compiler, for catching that for me. And there we go. So now we're back to OK there. I think we're in good shape. And I will go ahead and go to the Q and the A as well. Both the Q and the A. Work Handmade. Let's see. QA. So if you have any questions about what we just did, please go ahead and put them into the chat. And if you could, please make sure that they start with Q colon so that I will see them. I'm just testing out and make sure all this is working here. And it looks like we are in good shape. There we go. That's starting to feel pretty nice. Starting to feel pretty solid. Pretty happy with it. Got a bunch of work to do, obviously, to kind of solidify that Z handling even further. But we're getting to a nice place where now everything is specified in sort of a more canonical fashion, which means that also if Yangshin draws the bitmaps at different sizes, it doesn't matter now because we can tweak them exactly the way we want them to be, the right heights and stuff in the engine. So we're not like using the bitmaps as the height of things either. We're scaling them. So we got a lot of good stuff happening here. If that makes sense. So yeah, let's take a look here. Should the hero tree sizes not be dictated by the resolution of the art, i.e. to maintain constant pixel density, says Grumpy Giant 256. So I am not really of the opinion that a high-res game like 1920 by 1080 should be pixel accurate. And the reason for that is I think you give up too much if you go pixel accurate. So what I will want to do is I will want to have the size of the hero be potentially dynamic based on, you know, whether it's a certain unlock or whatever. I'll want every tree to be slightly different sized, right? So I will actually want to play with the scale as a way of adding interest to the art. And so I don't care at all about maintaining pixel perfectness. I think that's something that's a little bit more appropriate for a lower res game. If you're doing real pixel art, you maybe want that to be aligned or something like that. But once you get up to a certain degree of resolution, I don't feel like it's really that worth it. So I would rather throw everything at the bilinear blend, let it be a little bit blurry, but allow me to have that flexibility to scale. I feel like that just adds more visual interest than it loses. But that is certainly your decision. If somebody wanted to go the other way with that, I would not be at all upset with them, but I would point out the fact that since we're using sub-pixel placement, you're never getting a crisp pixel value anyway. You're always blending between 2 pixel values. So I think you kind of have to think about whether you really care too much about pixel accuracy at that point, right? Once you're moving things smoothly, I think pixel accuracy is not such a good idea. It's actually detrimental to the look. And so even if you were in a situation where you were trying to be pixel accurate, I would question whether that was like necessarily the right decision. I'd have to see the game, and you'd have to convince me basically. If you want your game to be full screen, how would you want to handle screens with different aspect ratios? So I don't know, and we'll have to do some work at that. We'll have to make that decision. I don't really want to deal with it right now because it's not that relevant to what we're doing, but it's a good question, right? If we were to play on a 4:3 display as opposed to a 16:9 display, what do we want to do? Do we want the player to see less of the screen and have to just deal with it and be like, hey man, if you wanted more field of view, you should have gotten a bigger screen? Or do we want to put like bars on the screen so that they get a letterboxed version? I don't know. And that's just a decision that we'll have to make. But it won't really affect our renderer. That's the aspect ratio is something we're able to play with a little more freely, so that won't really be a problem for us. We can choose to do different things in the future. Garlando Bloom, baby familiars. It probably has to happen. It probably has to happen, yes. I'll add it to the to-do file, but I mean, I think we all know it's the right thing. Let me take a look here. Okay. So in the reminders, let's go ahead and say little baby versions of yourself that follow you around and help. There we go. Okay. Noted. Tiny shadows look funny. You are correct. I never did go fix that size. We should probably do that. But you know what? I don't know how much we care about dealing with this right now, but I'll tweak those values a little bit. So let's see, underscore hero. And the shadow needs to be bigger. Hero size C. I don't know what the value should actually be. That looks about right. Looks Looks reasonably good. And then I guess we also have the problem here where we've kind of got like other stuff in here where we don't really know what we're doing, like the familiars and whatever. Those guys are totally scaled wrong. So I don't know what those should be, but you know, I guess that's not horrible, right? That seems pretty reasonable. And what about this guy here? That's the torso monster. Let's scale him up as well. All right. We could make the torso monster really big now if we wanted to. Look at how menacing he is. He's super menacing now that he's a torso monster, right? All right. Chronal Dragon. It could be interesting to have larger trees that span multiple Z levels. It's true. Of course, I'm not sure what that would actually mean because that would imply that you were climbing up and down something with a tree that you could see. I guess you'd have to be like climb up a little hill or something. I'm not totally sure. Will the game support scaling to arbitrary resolutions now? Yeah, I mean it does already, right? So if you like, you saw me switch it in there and it worked. So now you can set it to higher res and it just works. But until we optimize the renderer, you definitely don't want to do that. And even once we optimize the renderer, you probably don't want to ever run in higher than this resolution. I'm thinking on most machines. I mean, unless your machine's just a monster. Because in order to run in the higher resolutions, you'll probably want to run the GPU path, which we haven't done yet. Because basically, in order to run it like 1920 by 1080 or above, you're going to want the GPU because the GPU is the only thing that's got the horsepower for that. So in our CPU renderer, we're going to want to stay low res. That's going to be a trade-off we'll have to make. But that's fine. Like I said, the CPU renderer isn't something we expect players to use. It's just something we're doing to prove that we know how to do everything in there and that we understand everything that happens before we go ahead and use the GPU. But, you know, once we have the GPU in there, then that's the time when you can get a good frame rate on those higher resolutions. But the CPU render will support scaling to the higher resolutions. It just won't be performant at those higher resolutions, I would suspect. And the keyboard I'm using right now is a DOS Keyboard 3, for anyone who wants to know. Could you explain what the if and if stuff is and when, how you use it? Sure. Ifs and if zeros and end ifs are basically ways of me conditionally turning code on and off, right? And so typically when I don't want to deal with something right away, like there's a couple of different ways I'll do it, right? If I'm trying to work on porting some code to some changes, like I make some changes and I want to do something, I want to go through and make sure stuff works. Sometimes I want to isolate what I'm actually going to get working first so I can bring it up, test it, and then go and then work on a separate section later. So what'll happen typically, like let's say a good example here, we did it today multiple times, right? Is like I changed some variable, right? Like I'm going to go from a line to a line percentage or back, right? And you can see there's a bunch of code that's affected, and maybe I only want some of that code. I only want to work on some of that code. So what I'll do is I'll first comment out, right, effectively with an if. It's just like if I had done this, right? I'm effectively just commenting that code out with an if 0, and then I'll port the rest of the code, and then I'll come back to it, remove the if 0, and port it, right? So it basically allows me to sort of do a tiered approach to getting code working when I do some kind of a major change. That's one way I use it. The other way that I use it is to have stuff that I can just flick on and off depending on what's going on. So an example of that would be we wrote some test code down here for when we were doing normal mapping. And so you can see right now in the game, we're not running any of that normal mapping test code. But if I go in here and turn it on, you can see that now we're running the normal mapping test code, right? And so that's another thing that I use it for, is just to be able to quickly switch on and off pieces of code in a really easy way that doesn't you know, basically cost me anything to do, right? Will the stairs have different artwork for the top and bottom? And if so, how would you make them seamless? Per step artwork each at their own height? No, actually, I suspect that the stairwells will just be a bitmap. They're just going to be one bitmap. Because remember, at the level where you are, the stairwell is always in the correct place, if that makes sense. So I feel like it'll just work to just have the stairwells basically be sort of transitioned between the two. I'll have to think about whether there's anything else we need to do there. We may have to do something where we silently move them sort of essentially between Z levels, like we just adjust their Z height, or fade between them, but I think we might be able to get away with not doing that. I'm not sure. We'll have to see. But yeah, it's a good question, and I don't know the answer to it yet. We'll have to figure out how we want to do it. The problem we have basically is we're the only game I know of that handles being able to continuously move between Z like this. I've actually never seen one do it before, really, that has perspective. And so we're giving it a shot. What we can do is in the end, if we find that it's too hard, we can just change back to orthographic, which is actually trivial for us to do. We just stop doing the divide, right? So we can change back to orthographic at any time if we want to, and still keep the rest of the Z working the way it is. Can we at least get some crappy MS Paint programmer art stairs in there instead of yellow blocks? No. What happened to the cool velocity boost from stairwells? Velocity boost? I don't know. What velocity boost are we talking about? I'm not sure I know about the velocity boost. Towards the end when packaging, will you show us compression methods and ways to package all the art assets in one file? Packaging all the art assets in one file, yes. Compression methods, probably not. We'll probably do just a basic like zlib style compression. We probably won't really go into in depth on like, okay, if you really want to do compression, here's how to understand like all compression stuff, and because I'm not a compression guy. So we'll probably do some pretty basic compression, basically just an LZ compressor, and that'll be all that we'll do. And as for whether this game's going to be 2D, 3D, or isometric, it's basically like 2D art, but it's fully 3D in terms of like how we're allowing the world to work. And we're just doing that to basically show how you can robustly program the 3Dness so that we don't, so that people kind of can get a little bit of that learning. Is the hero supposed to shrink on the stairs? So the reason that the hero shrinks on the stairs, I don't know if you remember this, you should know why that is, but you may have forgotten. The reason is because of this. If you remember, we're one frame behind, lagging right now, on setting the Z location of the guy, right? If I remember correctly, right? Because camera relative ground P, this stuff here, I think we set the basis wrong. Now, I could be incorrect about that, but I think we are basically out of phase, if that makes sense, with where things are in Z. I'm not sure about that, though. Maybe we're not. Maybe that's okay. But I have to think about whether the camera and the guy are moved together or not. You know what? I take back what I said. I'm not actually sure if that's true. We haven't actually gone through and verified that yet. So I'm not actually sure. For the fading, it's definitely one frame of lag. But for the position, it might be okay. So maybe not. So that may only be because of the way the movement routines are working that he shrinks. Because it's whether or not the camera is getting updated properly with the ground value. So let's take a look at that. I can go in there and actually answer that question. That wasn't what I thought it was, but I'm not sure I necessarily know exactly what is the one frame lag behind. So let's take a look at how this works here. Okay. So we do all the movement here, and then when we do an NSIM, okay, yeah, so that's what it is. All right, so let me explain what it is. It is what I thought it was. Yeah, it is what I thought it was. So here's how this works, right? We open up a sim region and we begin sim. That maps all the guys into the sim region. We do a simulation on them by iterating over them. And while we are iterating over them, we push their bitmaps on. At the end, right, after we move them, we figure out where they are, and we say that is where the entity is in Z, right? Now the problem is, by the time we are doing this, we have not yet updated where the camera is for this frame, because where the camera is for this frame actually gets updated in here, nsim, after rendering has already occurred, right? Because that happens, that essentially means that the camera is always one frame behind where the guy is. So the guy moves down a little, one frame before the camera goes to follow him in nsim. Because remember, nsim, right, is where the camera motion happens. The camera motion happens right here in nsim. So in order to fix that, what we have to do, and we probably do want to do this at some point, is make sure that we stratify our updates properly so that we know where we have the renderer be informed of the camera's location at a time that is after the sim has closed out, which we can totally do. In fact, I'll put a to-do in here for it. Okay. Double semicolon. Are you upset about a double semicolon? Do double semicolons bother you for some reason? What do you have against a double semicolon? Why do you dislike the double semicolon? If you don't like a double semicolon, then I think the only answer is to make it 3 semicolons. Am I wrong? I feel like that's the right way to go. We ran out of questions. Thank you for streaming. It's always a privilege. Pre-stream was painful, though. Well, I'm sorry you guys had to deal with it. Once again, I don't say it enough, but thank you very much to the moderators for trying to keep the Twitch chat in line. I know it is not easy. It's always a bit of a struggle. I don't know who was here today. I guess Garlando, Bloom, Abner Combre, Chrono Dragon, and Drive 137. The whole gang, I think, was here today. Thank you guys for doing that. I know everyone appreciates it. I know I certainly do more than anyone. And like I said before, we talked about this privately a little bit, but I'm definitely going to do this. I want to set aside part of the Patreon money that comes in as part of this Pledge to Stream to do something nice for the moderators at some point. One of the things we talked about is if we have a Handmade Hero Con, we'll pay their travel expenses, that kind of stuff. So I want to do something good because I feel like it's important to basically, I want to try to distribute that Patreon money as equitably as possible. And I'm not the only person who contributes to making Handmade Hero good. And so, we definitely want to do something cool like that, but we just haven't actually had any sort of coherent idea of what that should be. So if you have ideas, feel free to post them on the board, but we would like to thank the moderators at some point for doing that work every day. It's a lot of work, and it's pretty thankless. I wouldn't want to be someone who has to deal with the influx of crazy Twitch front pagers, which happens sometimes, unfortunately. So anyway, with that in mind, thank you, moderators. We will definitely be doing some nice things for you with the Patreon money as we have the opportunity to do so. Like I said, I'm sure everyone appreciates it. I know I do, and we will find ways to say thank you as this project continues. For now, let me simply say thank you to everyone for joining me for Handmade Hero. It's been a pleasure coding with you as always. It feels really good to be cleaning up the code. I'm really happy with how the perspective stuff is turning out. I'm happy with how the Z stuff's starting to clean up. So I feel like we're really making good progress here towards solidifying everything. And once we get all that done, we can do some render optimization, which I think is going to be a blast. So I'm looking forward to it. I'm having a good time. I hope you're having a good time. And if you are having a good time, please come back and see us again tomorrow, 5 p.m. Pacific Standard Time, right here on Twitch. If you want to participate in the pre-stream and ask me crazy questions, we take off-topic questions during the pre-stream, you can come back tomorrow around 4:45 instead, because we do about 15 minutes of questions at the beginning. So I hope to see everyone back here again tomorrow. And as always, if you'd like to play around with the source at home, you can do so by heading over to handmadehero.org and pre-ordering the game. It comes with full source code, and I upload it every night after I'm done coding here. There's also a Patreon page, which I just mentioned, which basically supports the video series, and we hope to do some nice things for the community with that too, going forwards, like I said, as we figure out what the right things to do are there. So if you want to support it, that would be great. You can go there and you can subscribe. And we also have a forum site that you can go to, which has a place to ask questions, and it's got an annotated episode guide, and it's got ports to Mac and Linux, good stuff like that. So check that out if you're interested. And finally, we've got a tweet bot that basically tells you what the schedule is. And so that's a great place to go if you're just trying to catch the stream live, because sometimes we're off on various days or we need to move the stream, and that's a good place to make sure you always know when the stream is for that day. So if you want to catch it, you can catch it. That's it for today. Thanks everyone for joining me, and I'll hopefully see you again here tomorrow. Take it easy, everyone, and have a fabulous Tuesday until I see you next.